Multiplication is one of the first math skills students learn, and one of the easiest to bypass with AI. Type 6 times 8 into a chatbot and the answer appears instantly. But the real issue isn't speed. It's that too many tasks only ask for the answer in the first place. And without meaning, students struggle later with area, ratio, algebra, and even data interpretation. This episode is about building fluency that lasts, not just memorizing facts, but understanding multiplication deeply and using AI as a tool to explore, compare, and explain. Let's get into it. Step 1. Start with meaning. Begin with context. 3 groups of 4 apples, 3 rows of chairs, 3 packs of pencils. Then bring in AI. Show it on a number line, draw it as an array, or give it a real-world situation. Then ask students which model helps them most and how the models are alike or different. That's where meaning begins. Step 2. Instead of worksheets, have students prompt AI themselves. Have them create an area model for 6 times 8. Show 7 times 3 as an array and a number line. Then they sketch their own version, compare, and critique. Then they identify, did AI get it right? What's missing? This turns them into active thinkers, not passive receivers. Step 3, stretch number sense. Ask AI to show 5 times 4 in base 10, base 5, and with unit squares, or break down 12 times 5 as 10 groups of 5 plus 2 groups of 5. Students start to see multiplication as flexible and connected, not just memorized. Step 4 is connect to geometry and life. Multiplication lives everywhere. Have them use AI to create rectangles and compare the dimensions. Push further. Which one has the largest perimeter? Or move it into daily life. Ask them, when would you multiply 4.5 by 12? Students pick one example and build a short scenario around it. Math becomes visible in real context. Step 5 is mistakes as lessons. You can have students ask AI to generate a wrong model for 5 times 7. Then have students spot the error, explain why it's wrong, and have them correct it. Mistakes stop being dead ends and become teaching tools. Step 6 is to build layered challenges. You can give students a full sequence. 1. Use AI to create a multiplication scenario. 2. Represent it in 3 different ways. 3. Solve it with 2 strategies. 4. Extend it. What happens if the groups double? 5. Reflect on what this revealed about multiplication. That's how fluency gets layered step by step. And the last step is to grade for depth. Evaluation should value more than just the final answer. Use rubrics that reward modeling, strategy, explanation, and reflection. Speed and recall matter, but depth is what endures. Multiplication is not just a table to memorize. It is the foundation for area, algebra, proportionality, and so much more. If assignments only ask for answers, students will always find shortcuts. But when we redesign tasks to demand explanation, comparison, modeling, and reflection, we change the game. AI becomes a partner in thinking, not a way around it. That is the purpose of cheat-proof assignments, not blocking students, but designing learning experiences that are too meaningful and too layered to cheat. Fluency is built when students can explain why multiplication works, connect it to real-world context, and apply it in new ways. That is fluency that lasts. And that is how we keep math meaningful in the AI era.